Good afternoon, everyone, and welcome to the third and last session of the Dataviz Webinar Series, organized by the Copernicus Marine Service and Mercator Ocean International. My name is Marine, and I'm a training officer at Mercator Ocean International. I'll be your host for today. Before we begin, let's go over a few house rules to ensure you have the best experience during this webinar. First, please refrain from using the chat for questions. It's there for introductions, networking, and general discussion. Feel free to share where you're joining from today, what job you do, or even share a link to your portfolio or website if you have one. We would really love to find out about your work, as we'll be reading all messages from the chat. For technical or content-related questions, please use the Q&A button located on the top bar of the platform. Clicking on it will take you to a dedicated space where you can direct your questions to our speakers. There will be a Q&A session towards the end of today's webinar, so please specify who your question is for when submitting it. If you have trouble finding the Q&A button, we will also share the link in the chat throughout the session. If you weren't able to attend the first two webinars, or if you'd like to watch them again, you can do so directly from the event website on the Replays and Presentations tab. We talked about the Copernicus Marine Service and how to download the data, the evolution of data scales, the science behind phytoplankton blooms, and the thought process of a cartographer, amongst many other things. If you can, I really encourage you to stick around until the end of the session. I'll be sharing an exciting opportunity to have your ocean-themed data visualization featured at the 3rd United Nations Ocean Conference in Nice next June. This is a great chance to start working with Copernicus Marine Service data if you haven't already, and to showcase your work in front of key stakeholders and decision makers in the marine community. We've made the process as simple as possible with plenty of resources to help you along the way. Our goal is to bridge the gap between science and society, and your expertise in data visualization can make a real impact in shaping the conversation on sustainable ocean management. So stay tuned. I'll share more details later in this session. So let's start with our first speaker of the day. One of the goals of this series is to make ocean processes and phenomena easier to understand. That way, if you want to create a visualization using real data on this topic, you'll have a clearer starting point. That's why we're joined today by Amélie Loubet, an oceanographer at Mercator Ocean International. She specializes in the validation and monitoring of the ocean state, and she's here to help us understand marine heat waves, what they are, how they're typically represented, and the challenges scientists face in visualizing them. Amélie, are you with us?
Hello, everyone.
Hi, we can hear you loud and clear, so the floor is yours.
Thank you. So I'm gonna talk to you about marine heat wave. So first, what are marine heat waves? They are extreme rises in the ocean temperature. So we know that the ocean is warming due to global warming, and as a consequence, we have more extreme events such as marine heat waves. So here on this map, you can see the main marine heat wave that happened since 1995. And you can see that they can happen everywhere in the ocean, and they also can happen during summer as well as winter. So we know that because of global warming, they are becoming longer, warmer, and more frequent. And they often are monitored on the surface, but they can also extend to the subsurface. And they have a very negative impact on the biology, marine ecosystem, and human society. So it's really important to monitor them, and as well as at the surface and the subsurface. So to give you a more detailed definition of what a marine heat wave is, so we define a marine heat wave when the temperature, the daily temperature of the ocean is above the 10 hottest recorded values for at least 5 days. So to define this threshold, we take the temperature, the daily temperature of 30 years, and we look at the distribution. So as you can see in this figure, so you are used to hearing about the mean temperature, the climatology, and you know, when you look at the weather channel, they can say that today the temperature is 3 degrees above the normals. So here, for marine heat wave, we don't look at the mean temperature, but we look at the 90th percentile. So this is the difference between, this is the temperature above which there are the 10% hottest years. So we can see the 90th percentile here in this temporal temperature evolution. And to define a marine heat wave, we look when the daily temperature is above this threshold. And if it's above this threshold during more than 5 days, then we say that it's a marine heat wave. So when we know that we are in a marine heat wave state, we can define different categories, such as for hurricane, we define categories based on the speed, but for marine heat wave, we look at the temperature and how high the temperature is above the threshold. And we define so the moderate, the first category, the strong category, and severe and extreme. And then we can have maps like this, where we can see the marine heat waves categories over the globe. So this is a map for 22 of March. There is a mistake here. It's a 22. It's a forecast from Mercator, and that we published in the marine heat wave bulletin that we do weekly. And now that you know what a marine heat wave is, we can focus on the impact that marine heat wave has. So you see on this figure some of the main impact that can have, and they have impacts on different sectors. So of course on biology and marine ecosystem, because the water is warmer, so it can cause some thermal I mean, it's just like us when there is a atmospheric heat wave, we don't feel great because it's too warm. So it's the same thing for the fishes. So they can migrate towards higher latitude to find cooler water. And it can also lead to mass mortality. And we know also about coral bleaching because of warm temperature. And it can cause also loss of habitat for a lot of species. Regarding human impacts, that the impact that marine heat wave can have on humans, so it can affect fisheries, of course, because when there's less fish, there is less fish to fish, and it has negative impacts on coastal communities that rely on fisheries and tourism, and also it can lead to more extreme hurricane and more extreme weather, because when the temperature is warmer, then the hurricane gets stronger. So marine waves have a negative impact on biology, marine ecosystem, and human society, and we do need to monitor them to better adapt to them and also lower their impact on the biology. So we do weekly monitoring at Mercator Ocean, and in 2023, weekly monitoring revealed a big surface event in the North Atlantic tropical ocean. So you can see on this animation the categories throughout 2023. And you can see that the events started mid-March, and then it evolved toward the Caribbean Sea, and we reach really high categories. You can see that locally we have extreme categories. So we determined that it impacted more than 90% of the area was at one point during the year in the marine heatwave states. So this very big surface event led to a more thorough study, and we studied at depth at the subsurface, and we saw that it extended at depth. So here you can see on the animation the marine wave categories from the surface to 100 meters and from the surface to 2,000 meters. So this is the vertical cut of the ocean right here on this line. And you can see that the marine heat wave starts at the surface and then develops towards the depths. So we detected this marine heat wave, and we know that it started towards the eastern part of the basin, so off the coast of Spain and Morocco, and then it's evolved toward the Caribbean Sea. And also we know that it started at the surface and it evolved towards the depth. So to study this marine wave, we created a 4-dimensional database over time, longitude, latitude, and depth. So we have for each days sort of a cube like this. So the ocean is cut into smaller cubes, and in each cube we have a value of category, marine wave category. So it's either 1 for the moderate category, 2 for the strong, and so on. And if it's zeros, it means that there is no marine heat wave. So for every day, we have this 3-dimensional cube. And we have, for the entire 2023 year, we have 260 cube. And so we face some problem with data visualization because we only do two-dimensional map, as you can see here. So we have the surface marine heat wave here, and here we have the cuts, the vertical cuts that we previously saw the animation. But the problem is that we would like to visualize the 3D evolution of the events. So we would like to be able to visualize the pocket of warm water propagating toward the west and towards the depth. But we don't do this kind of visualization, so that's why I shared with you you can see the QR code here, and I shared with you all the data that we got from this study, so that you can maybe use your knowledge to help us visualize this very unprecedented events that happened in 2023. So to sum up, we have marine heat waves, which are extreme temperature events over a prolonged period of time. And in 2023, we saw a very intense marine heat wave in the North Tropical Atlantic Ocean, and it extended at depth. So we would like to be able to visualize its 3D evolution over the year. So thank you, everyone.
Thank you so much, Amélie, for that very clear explanation of marine heat waves. It was really interesting to learn about why representing them in 3D is so important for understanding and monitoring those events. So thank you very much.
You're welcome.
And speaking of 3D, our next speaker is an expert in this field and has some great examples and insights to share with us today. So I'm pleased to introduce Julian Hoffman-Anton, a data visualization designer, data science consultant, and researcher at University College London. He specializes in 3D mapping and visualization, using creative techniques to make data more engaging and accessible. With a strong focus on open source 3D methods, generative AI, digital art, and mixed media, Julian is always exploring new ways to present information. His goal is to make a positive impact on the world by transforming data into meaningful and visually compelling insights. Today, he'll be sharing his approach on data visualization. Hi, Julian.
Hello, everyone. Thank you, Marine. Thanks for the kind introduction. Yes, I'm gonna show perhaps a more creative way of visualizing this really hard science data that Amélie just showed us. And this is, I'm gonna start sharing my screen first. Sorry about this. Sorry about this. So hello everyone for joining. So again, this is a series out of 3 webinars. The first 2 showed a lot of hard science and beautiful visualizations. Today we looked at heat waves, and I will push it a bit further into a creative side to innovate and express ocean data a bit differently. But the main messages here again are amazing data from Mercator and so open source data, open source tools, and science from Copernicus Marine. The breakdown of this presentation is a very quick background summary. Then I will show you about the importance of data visualization, how important it is to communicate science. And then the most interesting part for you is obviously these open workflows that are available to anyone to innovate in data visualization beyond the ordinary. And the fourth part will be basically your turn. You can use everything I'm showing here. You can also do it. Quick background summary. You will notice I don't show a lot of text in my slides. This is a Dataviz talk, so I will summarize my life in a data visualization. So as you can see, I decided to split my life in the only 3 things that matter, which is economics, statistics, geography, and art. And there are ups and downs, and I think this is a cool way of showing your life. But then I started thinking, this doesn't make sense. There's art and geography, there is statistics and economics, and basically all of this is mixed up, and all of you are experts in your domains. And basically everyone has their own cake that is a beautiful mess, but they all have something in common. There is some visualization involved. Now, the more boring summary is, I don't know if you can see my, yeah. The more boring titles, I wear multiple hats. I do visualization for UCL and research. I do freelance stuff. I do spatial data analysis and motion graphics. But all of you are experts in many different things, and I'm sure you have degrees, and it's all multidisciplinary. So let's start with part 2 with data visualization. What is data visualization? You probably have your own definition, but I like to split it in 3 parts. There's art, there's data, there's communication. The data side is the science, obviously. There's the hypothesis, the hard science that Amélie just showed us, and Copernicus works on every single day. Then there's the art, then there's the communication. And there are obviously intersections. And the main thing is the core, which is image. It's an image with an ingredient, which is data. So the intersections are interesting, but we won't look into them today. And the key point about this presentation as well is that I like to make things that people remember. And how do we do this? By making this more interesting, just make it look more interesting and stand out in the overflowing load of information we get every single day. I used a generative AI for this and just creativity. So at the core, we have maps and data visualization. Now, there's the spectrum of data visualization. We won't have time to cover, but it's a whole lecture that we could do, but I like to split it into three parts. And on the left, we have data analysis. On the middle, we have data communication. And on the right, we have data viz for art. To the left, it's for yourself or for your team. It's really important for exploration, like webinar 1 exploration. For data communication, that's for an audience. That's for you. As it's not only for you, it's for the audience, and you have to convince sharing your insights. It's really important. And the third part is just for art, for yourself, for an audience. And we will look a bit into the yellow bit and mainly the middle one. But I still want to share one example of the importance and necessity of data visualization, which is this famous example. If we talk about heat waves, the average heat waves, it doesn't matter. The descriptive statistics are actually sometimes a bit are not meaningful compared to distribution spatially on the right. So you can see all these points have the same descriptive statistics, but only when you plot them and you see them visually, you see the dinosaur. So whenever you see an average or a mean or a standard deviation on a map, remember to plot it and discover errors or insights. Now, for the communication side, if you have to remember one slide, this is one of them. I've suffered from this formula. So when you have bad data, good analysis, good communication, you get wrong results. That's pretty obvious. Good data, bad analysis, good communication, wrong results. That's pretty obvious. But the third two pieces are really frustrating. When you have amazing data, satellites, super accurate, you have amazing scientists working on things, but you have bad communication, you get weak or no results at all. So what I want to say is visualization matters and communication matters. We want the perfect combo: good data, good analysis, and good data visualization. And of course, we have Copernicus Marine data in there. We have amazing scientists. We just need, and they already have really beautiful visualizations, but you can also do this to get true results. Another thing, let's dive more into the ocean side of things. There's the simplicity and the science. This is brilliant, but there are other options. We can do real art as well. But this pure art is not good for, I mean, there are different, it all depends on the audience. Then we have the complexity. This is really complex satellite data, super, all the details in the world, ultra complex, and the science behind it. Or we have another thing, it's complexity and art. So I created this visualization of Paris. But what we really want in this webinar is a balance. We want this both. We want this intersection of things. And obviously, we have to adapt to the audience. If we want to speak to a pure scientist, we have to balance this. But what I want to show is that we can go a bit further on the art side. And this is one of the examples I created. But this sounds a bit wrong because we are in the ocean visualization conference, and I removed the ocean here. So this is probably not the right thing to show. Let's get into the actual ocean. Open data from My Ocean Pro, and this is available to everyone. You can select whatever you want. There are so many, as you can see, there are so many interesting data sets with many features. And you're experts in your domains. But even when you're not an expert, you can explore this. So what I want to show here is not, oh, learn a new tool and give up your old data and your old tools. No, you can use open data in addition to your private and good data. You can use free tools in addition to your expertise tools, and just push one layer further to visualize things. It's really worth it. As we mentioned in the other webinars, you should check out. A lot of the data comes in this very powerful but potentially unusual. I mean, not that common, but very common in ocean science format, which is the NetCDF. So you can get this working and read this in R, in Python, in QGIS, and in Blender. This is all open source. I'm not promoting any non-open source things in this presentation. So let's get into it. How can you add this into your workflow? So on the left, we have the analysis. You have either programmatically in R, Python, or other things, or QGIS. And we saw in webinar 2 with Chiara Phillips, she did the analysis in QGIS and then also did this beautiful visualization on the right. Now in webinar 3, I want to show you all how we can add the third dimension and to make meaningful visualizations. And as I said, I'm not promoting any software. This is you can do everything you see, you can do it yourself. I use open source tools. Some here are alternatives you can check out. Now, this question is really important, and I really have to highlight 3D beauty equals more impact. Not always. I have to be completely honest. There are cons. Often it takes more time to create, but not always. Sometimes it's actually really quick and quicker. Then second point, it can be terribly unnecessary. So if it doesn't add anything, don't do 3D. It can be even truly counterproductive if done badly. So please use it wisely, only for fun, or don't use it without a reason, or just call me. Now the pros. So we humans, we are spatial beings, we are spatial animals. We are living a 3D world, so we really understand space. And when we see something in 3D, we see it physically. We have these emotions. We imagine it and feel it's real. So there are so many pros that I can go on forever, but we don't have time today. So now let's visualize ocean data, the world data in 3D. This is Blender. Let me start with an example. This is climate change and sea rise is absolutely essential. It's not a joke as a topic in the Netherlands. So this is one example where we worked on with Deltaris on flooding in flooding scenarios in ocean and sea rises. So when you have this type of plot, they are very common. This is all good to do science, share within the team, but once we want to communicate this with policymakers, with an audience, we need to add a better scale, more details and make it engaging. So it all depends on the audience. So what can you do? Because 3D, this is 3D and Blender, you can create the model, and the audience get a sense of the scale. We have realistic distances, reflections, volumetric clouds, etc. And because it's 3D and it's really powerful, you can change the angle and focus on the walls that are saving the city from destruction or flooding, etc. So we can go, I could go into many details of here, but this shows the power of visualization. People will recognize where they live. You get a sense of scale, and this is can be a poster and very powerful for the messaging. Now, let's continue with the ocean, where the ocean data is everything. Now we are under the ocean. If we remove the ocean, this is raw data, bathymetry and topography. But this is not, you cannot communicate like the information like this. So let's add another layer. Now we start to understand the shape of the world and the bathymetry, the height. But this is not enough to communicate. How about removing the distortion of the projection? And now we have a globe shape. This starts to look maybe a bit more unusual, less common. But can we go further? I think yes. What is very common in 3D is exaggerating elevation, because we can encode the information height into the image, and this is very classical, but it because it works. But now we can create a really physical object and that we can almost touch. Here I did not add labels or more information. I created this for this presentation. And the thing is, I couldn't pick just one visualization. I really couldn't help but create a series of visualizations to share with you. And we can also go beyond the static thing and create an actual 3D shape that feels believable. Again, this is open source, open data, open everything. As I said, now we can add, so this was without the ocean. Now let's add the ocean. This is the Copernicus globe current data. You can download this. This is sea surface. I think it's between 0 and 15 meters, black and white. This is raw data that you can interpret, but this is not enough to communicate the science behind it. And this is a lot of hard work already to just get this data, the science behind it. But I thought, okay, we can do something beyond that. We can make this engaging. We can use we have the particle directions. This is directly from Copernicus Marine service data, which I edited into Blender and added animation, motion, and etc. Exactly like this. Let's continue. There is the seawater potential water temperature. So all the data that Amélie used and actually worked heavily on it and did more science on top of the already the data. This is the forecast, but this is not good enough in just plain raw data. So we can start building things and explore the possibilities of making it a 3D globe in Blender, zooming into the most interesting parts of the globe, zoom in, zoom out, make animations. It's really there are no limits. It's and if you don't like to work with globes, you can also work on any shape, on a plain plain Earth map. So the limits are unbelievably far away. One last one, why not? We can even go crazier or even more surreal in terms of visualization. We have wind speed. I really like this because this goes beyond the ocean. It's the ocean wind surface from early this year, and this goes on top of land as well. So let's add the good color palette, and actually the color palette really matters for this. So can we add more? Now I put the map in this studio looking 3D space. This already is original, but I think we can add more things. Maybe the light is not ideal. Maybe we can add more contrast, different light, but maybe this looks a bit too flat. All this depends on the audience and of course on the purpose of the data visualization, because there are so many things that you can do. The artist and the scientist have to agree on what matters and what not. One visualization takes its decision making 100 times. Now I thought we can add texture, encode the information into an actual physical sphere. So I encoded the strength of the wind into the wind particles simulated into this physical 3D shape. There are details, there's photorealism, mysterious and surprising. And if you put everything together, I couldn't decide if it was better to make a 3D sphere or a plain map. So I didn't have to choose, I just did both. And now we have this animation that encodes so much of humanity's ingenuity, the science, the art, and information. So there's science, data, art, and important messages. And we saw how really high winds hit the US. We see all this, there's so much information in one image of 40 seconds. So I think, I hope I didn't scare you in terms of this is too creative. I think there is a whole spectrum. As I said, we can go from the ultra academic to the data art. There is a spectrum, but what I wanted to show you is some behind the scenes of these workflows that are available to everyone to communicate science. This is some behind the scenes. Here is, this might look overwhelming, but this is just a creative workflow I work with. You see all the software that is free to use. I hope you can get some inspiration out of it, but we won't spend too much time on it. It's your turn. I just wanted to show that the limits are, there are no limits. It's crazy what one person or one team can now create just with one laptop. And I haven't mentioned the use of large language models and generative AI, which add another layer that it could be another lecture on top of this. So the sky is not the limit. You can even do this for the geology of the moon. So the ocean, the world, planets, you can do a micro scale. It's pretty crazy. So what are the 3 takeaways? And I hope I didn't scare you. The first one, explore and experiment to stand out. The sky is not the limit. Secondly, science really needs visual communication. And thirdly, open source tools and open data are powerful and are evolving very quickly. So actually, people tend to remember only 3 takeaways, but I always add a fourth one, which is beautiful information is memorable and impactful. So thank you, by the way, for inviting me to give this presentation. Copernicus Marine was a true pleasure to organize this and work with the colleagues and learn about ocean data. So I hope you all enjoyed this series and we can connect and I'm here for the questions as well. So thank you very much. It's your turn to explore, explain, and express data visualization in new ways.
Thank you so much, Julian. I was so into it, I almost forgot I was hosting the webinar.
Thank you.
Thank you. So yeah, thank you for sharing these amazing visualizations and walking us through all these open source tools. I can see in the Q&A section that we already have some questions about those tools, so get ready to answer those a bit later. And yeah, it was really a great reminder that anyone can learn new skills and create compelling visualizations without needing expensive software or crazy knowledge that just a few people have. So yeah, it's super interesting.
I always thought I needed an expensive visual effects software to do this, but then I discovered no, there's so much to do. So please test it and start sharing it. That's what we want to do. Start sharing it with science, with the world.
Yeah, and there are a lot of interesting and useful tutorials that we've listed on the resources section of the event webpage as well. All of these are created by people who are not part of the Copernicus Marine Service, but they just created these tutorials and articles and added them online. And I think it's a really valuable resource to look into and to use to develop skills.
Exactly. Yeah. I also look. I had the chance to look into there are really very detailed tutorials on the use of NetCDF and sorry, I'm going through the slides, and there are really packages in R to read the data, and QGIS I also already tested, and Blender you can, if you do a deeper analysis there in Blender, there's a Blender add-on as well, and so many resources, and hopefully as many of you will test it.
Yeah, let's hope so. So yeah, thank you again. And before we move on to the Q&A session, we have one last presentation, and I will start sharing my screen. Okay. So as I mentioned at the start, I'll be sharing an exciting opportunity for your work to be featured at the United Nations Ocean Conference in Nice this June. This is a unique chance to have your visualization showcased in the European Union Digital Ocean Pavilion at UNOC, both at the exhibition and online afterward on the Copernicus Marine website. So let's talk about UNOC 3. This major event brings together governments, scientists, businesses, and citizens to accelerate action for ocean protection and sustainability. It's happening in Nice, France, from May 28 to June 15, 2025. and focuses on advancing Sustainable Development Goal 14, which focuses on the health of our oceans and marine resources. Key priorities of the conference include a stronger global cooperation for better ocean governance, more funding for conservation and the blue economy, and better science and knowledge sharing to inform policy. UNOC 3 isn't about reinventing the wheel, it's about amplifying what's already working and driving real, lasting impact for the future of our oceans. So now let's talk about how you can contribute to meaningful change. At UNOC 3, one of the key spaces will be the EU Digital Ocean Pavilion, which you can see on the screen. It will be led by the European Commission and implemented by Mercator Ocean International. And as the official French pavilion, which is especially significant since France is co-hosting the conference with Costa Rica, it will welcome thousands of visitors, including world leaders and top European officials. So, where does your work come in? The Engage section of the pavilion, which you can see on the right of the screen, is about educating and inspiring the public, government officials, and decision makers on ocean knowledge. If your data visualization is selected, it will be featured in the Beyond the Surface Ocean Data Stories exhibition, making ocean science more accessible. Your work will be showcased on interactive touch screens for visitors to explore, and some may even be featured on a large screen during high-profile talks, and potentially gaining visibility in events like the International Weather and Climate Forum. So the agenda of the event is still being decided at the moment, but we really want to give you the opportunity to have your work featured and shown to people. This is a really great opportunity to have your work displayed at a major global event and to inspire people and to contribute to the future of ocean conservation. So yeah, I would really encourage you to participate and don't miss your chance to be a part of it. So how can you participate? It's just 3 simple steps. Step 1, you can explore the data. So we've curated a selection of Copernicus Marine datasets to help you get started. You can browse through these to find an ocean phenomenon that interests you, or dive into the full Copernicus Marine catalog. Inside the folders that you can see on the bottom of the screen here, you'll find the marine heatwave data that Amélie mentioned earlier, amongst many other datasets, along with PDFs explaining the datasets, their sources, and some key details about it. We've made access as easy as possible so you can focus on the creative side of visualization. And don't forget, during webinar 2, we went through how to access the data, download it with David, who gave a very thorough presentation of anything related to accessing, downloading the data and visualizing it in the MyOcean Pro viewer that Julian mentioned earlier today as well. Step 2 is when you create your visualization and you bring the data to life. Use available resources, past Dataviz webinars and tutorials to experiment with different ways to visualize your data, whether as an image, animation, or video. And remember what Julian said, sky is not even the limit. So we really want to see your personal touch in these and see where you can take the data. And finally, step 3 is when you submit your visualization to be featured at UNOC, you have to do it before the 20th of May, but you can still add contributions after this date. And at that moment, your visualization will be added to the gallery displayed on the Copernicus Marine website. So once your visualization is ready, you can check the submission guidelines and send it in. We accept formats like JPEG, PNG, GIF, MP4, and MOV, along with a short description of your work. You'll obviously retain full rights to your work, and the gallery that you can see on the screen here will stay online on the Copernicus Marine website with new contributions added over time. So once again, this is a really good opportunity to make ocean science more accessible, inspire action, and be part of a movement for change. For more details, you can visit the UNOC 2025 tab on the event website, which you see at the top of the screen here. Another easy way to access pre-selected data that I wanted to mention is through Copernicus Marine's social media accounts. For many featured visualizations, a direct link to the data is included in the post. Just click on it and it will take you to the MyOcean Pro viewer, which we covered in webinar 2. And from there, simply hit the download button to get the data as a netCDF file. This is a great way to put your own spin on an existing visualization, so feel free to use these for your Beyond the Surface submissions. It works as well. And if you share your work on social media, tag the Copernicus Marine service. We're always looking for new ways to showcase our data and make it more accessible to the public. And before we wrap up on UNOC 3, this is just a quick reminder that you can find all the key links and resources on the UNOC 2025 page and the resources section of the event website where you registered. If you have any questions, our user support team is here to help. You can reach them through email, chat on the website, or you can browse through over 120 articles on the Help Center. We've also made a selection of interesting articles on the resources page of the website, and they're really interesting for people just starting with Copernicus Marine data. And also, don't forget to check out the e-learning section on the Copernicus Marine website, where you will find Jupyter notebooks, RStudio, and QGIS tutorials, plus video guides to help you access and download the data. Great. So now we can go to the last part of today's webinar, which is the Q&A session. So, thank you, Gaël. I think I'm going to start with question for Julian, maybe.
Yep.
And I will highlight this one. So this one is about the slide you showed about open data tools.
Yeah.
Someone would like to know that the R and Python libraries you listed.
Okay. Yeah. I'm sorry. I actually thought I was doing. I was too slow, so I was very quick on those slides. Let me share screen. Oh, wrong screen. Sorry.
Whoa, I've never seen myself so many times at the same time.
Sorry, this is.
That's okay, don't worry. Take your time.
I don't know what.
Oh, we see your presentation now. Yeah.
But I can't go out. Sorry. Anyway, this is the slide, right?
Yes, I think it is.
So the slide, I mean, this is not an exhaustive list at all. And there, because it's open source, there are always new packages being developed by very kind people, or so you have to keep checking if there's been an update, and So yeah, these are the R libraries. And the other slide of that might be useful is, I mean, here are open source alternatives to Photoshop, Illustrator, and alternatives to Esri with QGIS, etc. So this is another slide you might be interested in, and you can check it out as well. If you rewatch the presentation, you can spend more time on this creative workflow, looking at each step. This is for my workflow. You can add your expertise tools into this and start creating. So yeah, I hope that helps.
Thank you very much. I think maybe I'll go
back to the questions.
Another question for you, because Amélie had to leave the webinar for a bit, so we'll answer your questions, which there are quite a long list of, so I'll just highlight another one, which is, which programming language is used on the back end for 3D modeling?
I mean, the real backend be within Blender, I'm not sure, but so Blender has a Python script section. I did not use them. I don't use it that often, but that's a really powerful option. What I generally do is import, I do the analysis outside in RStudio or Jupyter Notebooks, etc. And I put the input into Blender, which can be a JPEG, like an image, or a TIFF, or a shapefile, or a SVG. So you do the analysis outside and you put it inside. Or with there are some add-ons to import directly netcdf data into Blender, but I wouldn't recommend doing hard analysis. I mean, it's not made for analysis, it's made for visualization.
Great, thank you. I will then go to maybe a question that was asked for Amélie, and she was able to send me some answers to this question. So hopefully I can just answer these. This one is, how can you add depth dimension just using Copernicus Marine Service data? And Amélie said that she used the Gloris 12 reanalysis product, which has 50 vertical levels, so it allows to look into depth. Reanalysis is a numerical model, but based on the physical oceanic equation corrected with observation data assimilation. So I hope this answers your question, and if it doesn't, please don't hesitate to ask another one, and we can always ask Amélie when she's back. So what we can do is go to another question for you, Julian, which is, can Photoshop be used for creating graphs, maps, charts, globe, and in case of dynamic data visualization?
So Photoshop is amazing, really, but for dynamic data, if dynamic depends what you define by dynamic. I think Photoshop can do something if you with MP4s and moving videos, but it's not ideal for dynamic things. To edit if you import for static things, you can definitely. I used it for many years to improve my maps and visualizations. It's just like photo editing. You can edit your maps for the final touch before the publication. So you can definitely use Photoshop, and there are open source alternatives to Photoshop.
Great, thank you. This is an interesting one. I'm not sure it has a definitive answer, but maybe you can give some insights into how you used to work, and what is the amount of time that one should dedicate to data visualization?
It's a good question, but it doesn't have a one answer. But the problem, I think, often might be that you spend in the data science, you spend often 50% in data cleaning, and then 30% on or 40% on analysis, and then you only have 5% time or 10 to do some visualization, and then you still have to publish more. So there's often not enough time spent visualizing, but I think you should spend more time thinking about the final result. As I said, if the analysis is amazing, the data is amazing, and then you don't spend time visualizing or communicating, then a lot of effort is wasted. So the answer is more more time.
Always more. Great. That's a good answer. I think this one as well is quite interesting. What do you think about the dichotomy between creating visualizations for scientific journal production, simple, and dissemination, more artistic?
This is a good question. For one thing is that I think in many scientific maps or visualizations, actually just making it simpler and more minimalistic minimalism is beautiful, and you can make something very scientific very minimalistic, not necessarily in 3D, but that's another question. But scientific, like there are so many amazing scientific papers and people. They're amazing at sciencing, but not at communicating that well. So you don't have to go crazy in the artistic way, just making things very clear. Clarity is beauty. So you don't have to decide. Sometimes it can be scientific and very beautiful.
Great, thank you. I suggest that we go to this one, which was for Amélie, but I'm afraid she won't be able to join again. So I'll answer this one, which was about the data set that she used for exploring marine heat wave. Is it in a global scale? Is there any local scale? So I think Gaël posted in the chat the product that Amélie used for this study. And this is a global product with 1/12 of a degree resolution, but marine heatwave definition can be applied to all CMEMS product, to all Copernicus Marine Service products, sorry, that has enough data to build long-term climatology, ideally 30 years. So I hope this answers your question. And I guess we could go to the next question, which was about data visualization of marine heatwave and whether they can involve MATLAB programming as well. And the answer is you can use whichever program you want. We provided a netcdf file in the list of datasets that I mentioned earlier and that Amélie referred to. We don't use MATLAB at Mercator Ocean, we use Python, but you're free to do it as you want, obviously. And I guess there's one last question, which is, I'm not sure we have an answer to this, but I don't know, Julian, if you've heard about something maybe. Are there any websites where you can find what people would like to have visualized, where you can help others do the visualization for them? I know we've talked about the Dataviz Society a bit during our time working together on this series, but I don't know if you have an answer to this.
I think, especially now, I mean, before the answer would have been clearly Twitter and just share it on some groups, or build a group of students that collaborate. Now it's a bit spread, but my recommendation would be to post it and get feedback from people, and don't be scared. That's how I started. I started posting my visualizations. I saw that was good feedback, and this feedback loop continued, and I kept sharing, and there are so many tutorials, so you can explore on YouTube, follow a video, and there are also comments under the video. So there are so many options to learn, but you have to dare sharing your first things that perhaps are not the prettiest yet, but you will get there.
Yeah. As you said earlier, it's all about kind of almost training to use these softwares, and I know in our conversations that you mentioned that you've spent so many hours on Blender, for example, and there's still so much to find out about this tool.
Exactly, and another slide I tend to share is that basically you can learn 20% of the tool and do 80% of all tasks. You don't need to learn all the buttons and things. If you learn the strong 10-20%, you can do most things, for sure.
That's really good advice. And I know of a visualization need that someone has. I mean, Amélie told you about this 3D visualization of marine heat waves that it's not super easy to represent because it requires that you actually know how to do 3D. So I think it's a really good start to start working on ocean data. The data is clean. It's exactly the one that Amélie showed during her presentation with the animation. It's just that in the data we made available for you, you also have the depth, the data in terms of depth. So I mean, I think this is a really great start to answer a need for visualization.
Exactly. The third dimension is really difficult, but and also the fourth dimension, which is time. It can be you can do things in 2D, and the third dimension is time. It's really it's a hard it's a hard topic, but and sometimes there is no good way of visualizing 3 dimensions or 4 or 5. So it's really there is science. You have to test, and yeah, but it's a fascinating topic to have the depth of the ocean, and also over time. That's the power also from the format NetCDF, that it can put those 5 dimensions, and up, down, left, and in time, and so it's a lot.
Yeah. I guess the next question is, I guess it's for all of us, kind of, but would it be possible to provide a tutorial or guidance on using Blender for data visualization? I know that, Julian, sometimes you do these kind of tutorials for groups. I know you did one quite recently,
Yeah.
but yeah, maybe if you can tell us a bit more about this.
So I haven't recorded and put online any tutorial. I've done several workshops, in one in London and one in Athens, and so I would need to record them, but you can learn a lot already from YouTube. That's how I self-taught many things. Again, I said Blender is for everything. It's not made for visualization, it's made for everything. So you can do, there's no limit. So you have to find the actual, you have to learn the basics unrelated to data visualization, and then you start putting your data inside and do what you want.
Yeah.
So I'm thinking of recording some tutorials, but I haven't yet. But if you subscribe to my newsletter or on Twitter, you will probably hear soon that there's a tutorial.
I saw someone in the chat say, I thought the Blender donut tutorial was nice and fun to learn the basics of what you
That's the
can do
one.
in Blender.
I highly recommend that donut tutorial. I did that tutorial. And so my advice is you do the basics of Blender, just the light textures and little modeling. And then you start doing maps and visualization. Don't learn both at the same time, because that's overwhelming. Do one first and then the data. And I got addicted to it, so it's very fun.
Really good advice. So the next one is about connecting data in RT dashboards, such as Streamlit. Is it possible to do this? I think it would be interesting to cross data sets and show how they interact. I don't know if, Julian, you have an answer to this.
And so RT, I'm not sure what RT means.
Yeah, I'm not sure either. So if you could just add...
But I think if there's an API from Copernicus
Oh,
Marine.
real time. It means real time.
Yeah. So there is I'm not the expert here, but there is the API. You can get the data through the API, so that can get, maybe it's not, I mean, I don't know, maybe there is some real-time data. I'm not the expert, but they have an API for sure.
Oh. Well, I guess we got to the end of the question. Someone said they recently registered for the London Data Visualization Blender workshop by you, Julian, but they were unable to attend virtually via Luma.
Sorry, so someone tried to attend?
Yeah, looks like it.
It was an in-person
That's why.
workshop. Sorry you couldn't, but if you send me an email, I could try to send you some files, but it was in person in London.
And maybe we can add your email address to the chat if you're okay with this, Julian.
Yes,
Yeah,
please
okay.
reach out. Reach out, connect. I'm very open with questions and.
Great. And then just another question popped up, which is about, is it possible to observe dashboard using Python programming? If yes, then how?
So with Python, you can do
Everything.
very complex dashboards. You can do whatever you want with Python. The question is like interactive or like dynamic with the API. I mean, with Python, you can do dashboards, yes.
The short answer is yes.
If you want to display maps, you can also, with the dashboard. I don't have a tutorial. I've never done it in Python. I've done it in R. Yes, with R Shiny, you can do that as well.
Cool. Thank you very much for the answer. And I guess I will just also mention that the replay of the session will be available on the Copernicus Marine Service YouTube channel and directly on the event website. In just a few days, we will send you an email once it's available. And you can also access the presentations from speakers. So hopefully we manage to add a presentation with all great animations from Julian's presentation. So yeah, thank you very much for your answers. And I think we can now go to the last section of this webinar and the last section of the series as well. So let me share my screen. Okay. So I really wanted to say a huge thank you to all our amazing speakers today and throughout this series. It's been an honor to have you with us, and we truly appreciate the time and effort you put into preparing and sharing your insights. Thank you as well to our participants today and to our 2 previous webinars. I hope you all learned something new. I know I did. I definitely learned a lot of things during these 3 webinars. Before we wrap up, I just wanted to give you some final information. In the Q&A section of the website, there's a quick poll you can take on the right. It only takes 2 minutes, and your feedback will help us improve future sessions. We've compiled useful tutorials, videos, and Help Center articles in the resources section of the event website. If you have suggestions for additional resources, let us know in the poll. The webinar recording and presentations will be available in the coming days on the event website, and you'll receive an email once they're ready. In the meantime, you can already watch the replay of the first 2 webinars. So that brings us to the end of the Dataviz Webinar Series. A huge thank you to all speakers and participants. Your engagement has made this series truly special for all of us. If you're feeling inspired to dive deeper into working with Copernicus Marine ocean data, don't miss the upcoming Copernicus Marine Essentials webinar series. It's designed to help you explore, access, and use ocean data with confidence. You can find out more about it through the link we're sharing in the chat now. And if you're looking for a way to showcase your work, don't forget about the Beyond the Surface exhibition at the 3rd United Nations Ocean Conference. It's a unique opportunity to have your data visualization featured on a global stage and contribute to making ocean science more accessible. Thank you again for joining this series. We hope to see you in the next one.
Thank
So
you,
bye for
everyone.
now.